Welcome you all. In this section, we're going to explain about the estimation of a multiple regression model. That is, the derivation of the estimates of the parameters. For the estimation purpose, we used this equation, that is yi equal to beta 1 plus beta 2 x2i plus beta 3 x3i plus ui cap. This is a three variable regression model or multiple regression model, and here the ordinary least square method is used for the derivation of the parameters beta 2. Like the two variable regression model, here also we are using the OLS estimator, and here the OLS criterion is used for the estimation, that we are minimizing the sum of squares. We know why we are using the sum of squares. The reason is that if you add the error terms, it will give this 0, its value will be equal to, or sum will be equal to 0. Therefore, we uses the sum of squares and then minimize the given function. Here the sum of squares of error term can be, from the sum of squares of the error term can be derived, that is sigma ui cap square equal to this yi minus beta 1 minus beta 2 cap minus beta 3 cap the whole square. Earlier this is like the two variable regression model. Here also the number of variables will be different. In the multiple regression model, in the same way, here the number of variables will be more. The method will be the same in the three variable regression model, multiple regression model also. Now differentiate this equation partially with respect to three unknowns. That is, three unknowns are, what are the three unknowns? Beta 1, beta 2 and beta 3. These are the three unknown variables. Then differentiate or take the partial differential of the dou ui cap square divided by dou beta 1 cap. Then it is the same way, 2 into sigma of then it is like u square, that is 2 into this 1 into differentiate with respect to this beta 1 cap. First one, the differential of beta 1 cap is 1 and therefore minus 1. Like that, differentiate it with respect to the beta 2 cap. Here the differential of beta 2 cap is minus x2i, that equal to 0. Beta 3 cap, the differential of beta 3 cap is x3i then into x3i. These are the partial regression equations of this model with respect to three unknowns. Three unknowns are beta 1, beta 2 and beta 3. From this we can derive three normal equation. This normal equation equal to, like that, equate this to equal to 0, then apply the following the following rules, that is sigma ui cap equal to 0, sigma ui cap x2 equal to 0, sigma ui cap x3 equal to 0, etc. Then here the first normal equation we have. From this we can derive three normal equations by applying the rule sigma ui equal to 0, sigma ui x2i equal to 0, sigma ui cap x3 equal to 0, etc. And from these three partial regression equations we can derive three equations, normal equations. They are sigma yi equal to n beta 1 cap plus beta 2 cap sigma x2i plus beta 3 cap sigma x3i. Then second equation will be, the remaining portion will be sigma yi x2i equal to beta 1 sigma x2i plus beta 2 sigma x2i square, this x2i and x2i square, plus beta 3 x3i x2i. And the third normal equation will be sigma yi x3i equal to, then multiply all these terms by x3i and distribute sigma summation terms, that is sigma yi x3i equal to beta 1 cap sigma x3i plus beta 2 cap sigma x2i x3i plus beta 3 cap sigma x3i square. These are the three normal equations we can derive from this equation, and it is given here. Here the y bar equal to beta 1 cap plus beta 2 x2 bar plus beta 3 x3 bar is given. Here it is by dividing the first normal equation. First normal equation was sigma y equal to n beta 1 cap plus beta 2 cap sigma x2i plus beta 3 cap sigma x3. This was the first normal equation. Then divide the whole equation by n. The result is given here. That is y bar equal to beta 1 cap plus beta 2 cap x2i plus beta 3 cap x3. From this we can derive the value of beta 1 cap directly. That is what is given here. Then second normal equation is sigma yi x2i equal to beta 1 cap sigma x2i plus beta 2 cap sigma x2i square plus beta 3 cap sigma x2i x3i. Third normal equation is sigma yi x3i equal to beta 1 cap sigma x3i plus beta 2 cap sigma x2i x3i plus beta 3 cap sigma. These are the three normal equations. From this beta 1 cap equal to y bar minus beta 2 cap x bar. Earlier we have derived beta 1 cap like in the two variable regression model. Also we derived it like beta 1 cap equal to y bar minus beta 2 cap x bar. Here beta 1 cap equal to y bar minus beta 2 cap x2 bar minus x3 bar. This is the equation for the. From this we can derive the equation directly, the value of beta 1 cap directly. And likewise we can derive the beta 2 cap and beta 3 cap by solving these three normal equations or two normal equations. The values of beta 2 cap is given here. Sigma y x2i yi x2i in sigma x3i square minus sigma yi x3i into sigma x2i x3i divided by sigma x2i square into sigma x3i square minus sigma x2i x3i the whole square. Likewise the value of beta 3 cap can be calculated as sigma of yi x3i into sigma of x2i square minus sigma of yi x2i into sigma x2i x3i divided by sigma x2i square sigma x3i square minus sigma x2i x3i the whole square. Here the denominators are the same. What we are doing here, we are subtracting the square of the product from the squares of the two partial variables or two independent variables. x2i and x3i are the two independent variable. Its square, sum of square, its product is its product minus this sum of squares of the products. This we can extend these normal equations. This we can extend this into k variables. Like we can minimize the or we can increase the number of these two k variables. Then we'll get the normal equation by taking the or after taking the partial derivatives or the partial coefficient. After taking the by minimizing the sum of squares, we'll get the following partial regression equations. From this we can derive the normal equations we can derive the various parameters. Here there will be k parameters. The first equation is sigma y equal to n beta 1 cap plus beta 2 cap sigma x2i plus sigma beta 3 cap sigma x3i plus up to beta k sigma. Then sigma yi x2i beta 1 cap sigma x2i x2i square x3i x2i then x2i x3i. Here the third term. Likewise we can derive the the normal equation for k unknowns. Here the small letter the deviation form is given. Here the variance of beta 1 is variance and standard error of beta 1 cap are given. Variance of beta 1 cap equal to 1 by n plus x2 bar the whole square sum into sum of x3i square plus x3 bar the whole square into sum of x2i square minus 2x2 bar x3 bar sigma x2i x3i divided by sigma x2i square sigma x3i square minus sigma x2i x3i the whole square into sigma square. And likewise variance of beta 2 cap equal to sigma x3i square divided by sigma x2i square sigma x3i minus sigma x2i x3i square into sigma square. This can be written as sigma square divided by sigma x2i into 1 minus r23 square. This is the partial regression coefficient, partial correlation coefficient. Then standard error of beta 2 cap is root plus or minus root of variance of beta 2 cap. Variance of beta 3 cap is here sigma x2i square divided by sigma x2i square, sigma x3i square minus sigma x2i x3i square into sigma square, or sigma square divided by sigma x3i square into 1 minus r23 square. Here variance of beta 2 is sigma square divided by sigma of x2i square into 1 minus the partial correlation coefficient. Here variance of beta 2 cap can be written as sigma square by sigma x2i square into 1 minus r23 square, where r23 is the sample coefficient of correlation between x2 and x3. Sample coefficient of correlation between x2 and x3 is the r23. And standard error of beta 2 cap equal to plus or minus root of beta 2 cap. Likewise, the variance of beta 3 cap equal to sigma x2i square divided by sigma x2i square, sigma x3i square minus sigma x2i x3i square into sigma square. And variance of beta 3 cap can also be written as sigma square divided by sigma x3i square into 1 minus r23. That is, the r23 here is the sample coefficient of correlation between x2 and x3. Sample coefficient of correlation between x2 and x3. And standard error of beta 3 cap equal to variance of beta 2 cap, root of variance of beta 3 cap. And the covariance of beta 2 and beta 3 equal to minus r23. The r23 is the sample coefficient of correlation between x2 and x3. Sample coefficient of correlation between x2 and x3 into sigma square divided by 1 minus r23 square root of sigma x2i square root of sigma x3i square. And sigma cap square equal to sigma ui cap square divided by n minus 3. Earlier it was sigma ui cap square divided by n minus 2. Here we have the number of parameters to be estimated are 3, and therefore n minus k is the formula here, sigma ui cap square divided by n minus 3.